So tonight we're going to talk about LangChain, and it's quite interesting how quickly this thing blew up. It's amazing. The first commit was made in late October, and since late October until now, uh, there are over 900 contributors helping and over 46,000 stars that it got. So people are just actively developing. It's growing like crazy, and it's an amazing tool. It's just the whole principle behind it is to be a higher level library for when you are working with uh, large language models, right? So that's its core. That's its purpose. Just try to make your life as easy as possible when you work with those models. So uh, basically, an example here is kind of like LangChain. Almost, it's like the glue between all the parts of an application, right? So this example, you have a user that has a question: how much is 2 plus 2, right? It's passed into LangChain, or actually you're using the LangChain API to right now take that question, convert it into use an embedding model that's a large, an LLM basically, large language model, and you will get back a question vector. That's kind of like in this format, like it's a long list of numbers. You can take that one, and if you want to store it, so for example, in a more complex application and where you would have a lot more data, you would just basically use a vector database. This example, it's from Quadrant. Quadrant, it's one of these newest uh, vector databases, and you can store that vector data in there. We had a discussion a few weeks back about vector databases. I'm not sure if you guys are familiar with them, but basically, vector databases are designed to accept these vectors and very quickly do searches on kind of like a certain similarity. So if you have a vector, it would go into that database, find the closest vectors to it, and return the metadata attached to that vector. So the metadata would be the actual text or other information that you want to attach to it. But it's that whole searching part, that similarity search, that they are great at, right? So you'd have this one. So once you get the embedding model, you get a question vector. Again, you're using the LangChain API to pass this question vector to the database and return the closest facts that are to that question, right? Now, once you get that information, again, you can use LangChain this time to connect to a large language model like an OpenAI, like the GPT 3.5 or GPT-4, or any other ones or any other open source ones. And you basically would pass that information that came from Quadrant together with your question. So basically, the information that came from Quadrant, it's like a context. So it's what the language model uses as a context to answer your question. So right now, once you pass the prompt with your question and with the facts, the large language model will get you a way better answer than it would have given you before, and returns the answer to the user. So this is basically kind of like a general approach to like a LangChain application, right? So it's pretty straightforward. I mean, it looks a lot more complex than it is. A lot of this stuff, it's happening behind the scenes, and you'll be amazed to see what you can do in about 20, 30 lines of code. So, okay. So like I was saying, basically the core idea of the framework is that we can chain together different sources of computational knowledge together with LLMs to build data-aware and agentic applications. This is basically their definition. So it allows LLMs to be passed more information or other kind of like a calculator, tools and other things to help them generate the right response, right? I'm not sure if you tried it lately, but if you try to put like a simple, like a how much it's 2 plus 2 type of question in GPT-4, you'll get the right answer, but the GPT 3.5 might not. And other of the open source ones, again, might not. But it's a lot easier to just kind of like have a calculator that you know it can use in LangChain would allow you to create that interface to tools that would be able to actually give you help you with the proper answer, right? So it can be used for a lot of things: chatbot, question answering, summarization. They have modules that you can interact straight with APIs, and the autonomous agents are basically kind of like decision. When you don't have a clear path defined for the algorithm, for the model to follow, you can use these decision-making autonomous agents to create that path. But we'll talk a little bit about that later. So there are 7 modules available in LangChain, and these are basically the building blocks for any LLM-powered application. So the first one is the models. That they're basically at the core of everything. So that's the integration with models, and you either integrate with OpenAI's API, with Cohere, or any of the open source ones. They're basically having ways to very quickly integrate with them, pretty much everything. Prompts are, everybody's familiar right now with how you're actually asking a question to ChatGPT, right? And prompt engineering, it's one of these huge things that took over lately, where you're trying to refine your questions and present them in a certain way so the model has a higher probability of giving you the right answer. So the prompts module allows you to create all these prompt templates that you can work with, and that way every request that you're making is kind of like uniform and has that kind of like unique way that you found working, right? Memory, it's basically like we were talking earlier in this stage, the quadrant, where you would store the data, and there are different ways. I mean, you can do in memory, or you can just kind of store it locally, or you can work with other kind of like cloud hosted databases. Indexes are basically at the core of everything. So I'm gonna talk about indexes a little bit in detail when we get to them. Chains are basically these connections, if you want. It's kind of like the higher level over the connection with the model, right? And you can chain things together using these chains. You can actually pass multiple calls together into it. Agents are kind of like on their own. Like I was saying, if you don't have a clear path, you can use an agent to do what kind of to decide what to do, basically, and create a path. And the callbacks are just ways of interacting and intercepting information and returns and everything throughout the application's runtime, right? So those are really good for if you have like monitoring the application, or if you're kind of recording steps and try to get all that stuff from it. Okay, models, right? So currently, LangChain works with 3 types of models. The large language models, right, that basically provide the core functionality. They are the core of everything. And then the other one is the chat model, which it's basically a level up above the large language model, above the LLM. LLM, usually you just pass a string and you get a string back. With a chat model, you're actually, every time you're passing a string and you get a response, you add those 2 a hierarchy, a structure of messages, right? That a history of what it's been asked of the model and what the model responded. And that history keeps on being passed back to the model, so the model has a context of the discussion. So that way, this is one way of kind of build memory, right? And the way you're passing this is passing through a list. So the chat models accept a list of inputs, and they return just a one string as an output, right? And the text embeddings, for who's not familiar with the embeddings, basically they are a vector representation, so a list of numbers, representation of a piece of text, or they can be done for images, they can be done for audio, they can be done for video, for pretty much anything. But here, LangChain deals only with the text embeddings, right? And for the text embedding, you would send a piece of text, and you would get that representation back, the list of basically the vector. You'd get that back, right? So it's very easy. Just from LangChain, LLMs import OpenAI, and then you can have LLM equals OpenAI, and then just predict and say hi, and that's gonna return something back, right? So that's a way to deal with that. The same thing with the chat model. You just instantiate the chat OpenAI as a chat model, and then you just run the predict, and you'll get you'll pass a message. And to this predicts for the chat, you can actually pass a list of messages that you keep on growing, right? And for the embeddings, the same way, you instantiate the embeddings model, and then you just embed the query, and then you'll get a vector back. So all this stuff that you would have actually run the requests library and doing all this extra work to interface with their API, it's all just kind of like hidden behind the scenes. So it makes your life a lot easier when working with the large model LLMs, right? So the same, we're talking about prompts earlier, right? So it's basically a very simple way of working with them, where you create this prompt template. So from template, tell me a joke about subject, right? And now you're just passing format prompt, and you pass the subject, and that subject is going to be replaced. You can do this with like string formatting in Python, very easy. But the library here, it's kind of like makes it more unified, and you keep it underneath LangChain, basically. So you can make it as complex as you want. You can actually pass, you can have multiple subjects, no multiple subjects, multiple kind of replacement parts, right, in that prompt, and you would pass them in a list rather than just kind of subject equals soccer. So, or actually you would pass them, sorry, as a dictionary. And the same thing, it works the same for the chat prompt, right? So memory. So remember what we were talking about in the beginning, when I was saying that you pass that historical data in the chat, and you just kind of like get it back. They've made this whole kind of like conversation buffer memory, and this is one of them. There are a few other ways of storing memory, but this is one of the easiest. So you're just adding, you have different types of messages, especially if you ever looked at the OpenAI documentation, you have system messages, you have the user messages, and you have also the responses back from the AI, right? So this one basically allows you to kind of like chat memory dot add user message, and then dot add AI message. So this adds to that list of memory. And then when you are kind of dealing with the language model, when you instantiate the model, you're basically passing that memory in here. And that way, when you're running a predict, it's going to say that, hey, current conversation, human, hi there, AI, and just basically the AI returns, hi there, it's nice to meet you, how can I help you today? And then next time you run, I'm doing well, I'm having a conversation with an AI, you could see here the current conversation. So you would see the old, hi there, it's nice to meet you, and I'm doing well, just having a conversation, right? So every time you're asking something or the AI returns something, you would get that just basically added to the memory. Indexes, right? So indexes are a little bit more complicated, but they're again kind of like a fundamental part of this. So they're just the way you are dealing with all the data and the documents that can that the LLMs can interact with. So you have document loaders, right? So you can just, let's say you have a folder that has a ton of PDFs in it. You can load them all, right? You want to get information from a CSV the same way. You want to scrape a page and get a contact, all the text from an URL. You can do that. You can automatically connect to Wikipedia. Either kind of like all the AWS, GCP, clouds, Azure, you can connect to those as well and get data back. Slack, Twitter, all of these. So it makes it very easy to find this information and get it in. Now, text splitters are ways to basically bite-size that information, right? So if you think of it with OpenAI, right? If you worked with GPT 3.5, you know it has a memory of about 4,000 tokens. Right now they've just updated, and I think it's 12,000 or 16,000. I don't remember. It was in the news a couple of days ago that they've pushed 3.5 with a lot longer context. So it's not as big of a problem. But let's say if you deal with a document that has 500 pages and you need to kind of try to work through that, you still cannot send all the documents as a context, right? So what you want to do is break it down in little bits and pieces, certain size, let's say 1,000 characters or so, and use those to create embeddings and store them into a vector database so that later down the road, when you're searching for a certain thing, the first operation that you would do is embed your question, run an embedding for your question, then search the database for all these little chunks of text that are pertinent to your search, and use those as a smaller context together with your question and pass it to, right? So that's what the text splitters do in general, right? And vector stores are basically that database that I was talking about, right? You store the documents and embeddings and just kind of allows you to do all these quick lookups. So vector stores are quite useful when you're dealing with large language model, especially when you have large data. And the retrievers are basically the interface to just kind of getting this data and processing it in a fast way to be passed and back and forth with the model, right?
Hey,
yes.
What is a semantic splitter, or what does it accomplish? What does it give you?
So semantics, so you have different types of splitters. You can just go, the simplest possible one is by character. And you say, in this text that has 100,000 characters, split it in chunks of text that are 1,000 characters. End of story. The semantic one, it's basically try to find sentences and break into paragraphs and other things. I haven't used them, but just basically all the stuff that I've done worked quite darn well with a simple character splitter. So, but that's the idea behind it. It's just kind of trying to split it based on sentences, paragraphs, and everything. And thank you for the question. And if anybody has questions, don't wait until the end. It's better to just kind of ask right now when we're talking about this, right? So thank you for that. Okay, so that's basically what the indexes are, right? The way to structure documents for ease of interaction with them. Now the chains. So chains allow you to combine all these things together and run them one after the other, right? So here the example, for example, we can create a chain that takes user input, formats it as a prompt template, then pass it to the response, the formatted response to a large language model. So that's a very simple way of doing it. You can build it as much as you want. For example, you can actually work with multiple models and get data in different ways. One of the examples that I wanted kind of to show towards the end, I'm not sure if I still have it open, but they were creating, so they had this prompt model that you would pass in a subject, right? And based on that subject, it would first generate a title for like a YouTube video, and this would be one of the models that would generate that, and then they would have another model that would take the title and the original question, the subject, and generate a whole YouTube script for it, right? And this was done in a few lines of code. It's insanely easy to do that, right? So there are multiple types. So there are multiple types of chains. So kind of like, let's look over this one. So first of all, you kind of instantiate the large language model. Then you create your prompt template with kind of like the product being the input variable, and then what is a good name for a company that makes this product, right? And then you create the chain by instantiating an LLM chain, which is the simplest way. And this is kind of like a one thing. It's not chained together. It's just a simple one-time call, pretty much. And you pass the language model, you pass the prompt, and then you run it. And the answer, colorful toast company. You know, so it's pretty straightforward to do this, right? Now, let's say you want to do another thing where you want to write a catchphrase for the following company and company name. So you create this second chain, which is another LLM chain. And then you can chain these two together using the simple sequential chain, and you put the original chain and the second chain. This verbose true is quite an interesting parameter because it allows you to see exactly what the model does. And especially for agents, it's quite interesting to see the steps that it takes and how it thinks about everything and how it kind of moves forward, right? And whoops, sorry. Okay, so this one, and then you run it, the overall chain now with passing that colorful socks, and just basically right now, because it's kind of set like this, it will return only the last one. They put a little rainbow in your step. It doesn't return the original one as well, the whatever it's called, this one, the name of the company. But there is a way to do it. It's a little bit more complicated, and if you use a different type of sequential chain, you don't have to deal with that. So, but this is kind of like for now. So like I was saying, agents, these are kind of like the more complex things in here. And they're kind of also the ones that are the more prone to break because you're actually expecting the model to make all these decisions, which sometimes if you don't give it the proper information, it's a little bit iffy. But it's basically when you don't have a clear and predetermined chain of calls, right? When you have an unknown chain that depends on the user's input. So this is what an agent is, and agents have access to tools, and the tools are functions that you can use that the models or the agents can use to interact with the world. So one of those tools would be a Google search, right? You have the opportunity to go and search Google for whatever the model needs and returns that data back, and you work. The model works with it. The same with like Wikipedia. So you can go search Wikipedia and get all that. You can search a database for things. So these are basically agents and tools are kind of working hand in hand. So, okay. And there,
Anton, quick question. So is
yes,
it an agent what you would use if you want to say do a mathematical calculation, but you don't want the LLM to do it because you don't trust it?
right. You can do that. You can actually do that. If you create a calculator function, or you have a tool that's designed to do that math, you can actually pass it to the agent, and the agent will be like, oh, I can use this thing, and does the math and returns back the answer. Yes, definitely you can do that.
So it's you can imagine it like a bunch of if conditions, and depending on the if condition, you can call any API in the world.
Right, but the way they're doing it is when you design the chain and you design the agent, you're saying it, hey, you can have access to this tool and this tool and this tool. So you pass just a certain limited amount of tools that would fit the purpose of your application, right? You cannot say that, hey, these are all the tools that LangChain allows to, and these are all other tools that I can find online. Let's put them all together here and let the agent try to choose. It's going to get even more confused. So you got to try to make sure to still steer it the way you want, right? So it's just it's a lot harder to do something like a full-blown GPT or like ChatGPT, right? Even there with the plugins, you just choose the plugins that you want to work with, and you pass those, right? So it's all kind of like they're still not really smart. They're still making a ton of mistakes on these models. So the more you constrain them, the better they'll return whatever you're expecting. You know, the better they'll perform. So,
okay,
makes sense. Okay,
I do have a
so
question.
yes.
I was wondering if, let's say, you add documents to I don't know, whatever AI you're trying to work with, and let's say that documents are all analyzed and then vectorized. Can you make an agent basically point queries for documents towards, like, let's say PyTorch, where your GPU can hash through all the vectors in order to find what you need, and then pass it back to your CPU so that you don't have to wait on your CPU to try to hash through, let's say, 500 books?
Well, it's so basically that's what the vector stores were designed for. All the stuff that you said, where you have all that data, all those 500 pages or 500 books, you have them already vectorized in these little chunks within the vector store, right? Within the vector database. Now, kind of like this whole example in the beginning, right? Question a vector, and the database returns the top K facts. So that whole searching through and finding the ones that are similar to your question, it's done by the database. In the database, I was showing an example about a month ago where I worked, I think it was like, there were like 200,000 images that I've vectorized, and I was searching, and there is the result. And I mean, this was using Pinecone, which is a cloud hosted database, vector database, and the returns were within like milliseconds. So these are basically the vector database are the ones that are designed to do all that operation. LLMs don't deal with that. LangChain doesn't deal with that, right? So the vector databases are the ones that are searching for similarity and returning all the stuff back.
So then your agent wouldn't be a tool, or wouldn't be something that can point towards, like, let's say PyTorch, so that you can utilize your GPU then?
No, so basically,
Gotcha.
you don't have to involve any PyTorch, you don't have to involve anything for that similarity search. It's all done within the vector database.
Well, I understand that. It's just that I have a problem personally with my vector databases all being utilized by my CPU. So when you said the agent can point towards a tool, I was thinking, okay, well, then maybe the agent can just simply point towards a function, which is, you know, using PyTorch, for example.
I would assume, yes, you can definitely do that because you can write your own tools, you can write your own agents. So definitely you can do that. Yeah.
Okay.
But I mean, it's going to be hard because the vector databases are already designed to work super fast. There is one that's in memory that's by Facebook called FICE, but I'm not entirely sure if it's using GPU to parallelize. But they're very, so for the vector databases, they create indexes when you insert the data into the database. So that way, when you do the search is insanely fast. So most of that figuring out distances and similarities and all that stuff, you are just basically, when you're inserting, you're adding those measurements. And then when you search, because the data is already there, it's very easy and it's already clustered. It's very easy to find similar things. It's insanely fast. And I think Philip was saying in the chat that Weaviate, he thinks Weaviate has modules to support GPU. I haven't used Weaviate at all. So there's so many. So maybe that's what's going to make it even faster. Oh. And LangChain works easily with Weaviate. It's just pretty much like with Pinecone and all the other ones. Make sense? Okay. So agents, right? So there are two agent types in there. So the action agents, where the user input is received, the agent decides which tool to use, right? And what the tool input should be. Then it calls the tool and it returns the observation. So basically the observation is recorded and it's just basically returned to, well, number 4, basically the history of tool input and observation is passed back to the agent that decides the next step, right? So, and this repeats until the agent decides no longer needs to use a tool. So it's basically all this information gets passed to an LLM and the LLM makes the decision of what to do next, right? And it just keeps on repeating this until it gets it. And then the other one is the plan and execute agents, and the user input is received. The planner part lists out the steps to take, and the executor goes to the list of steps executing them. So the action agents are the ones that are mostly used. I haven't used the plan and execute yet, so, but these are kind of like the main ones. Yeah. Okay, so these are the callbacks. Like I was saying, the callback systems allow you to hook into various stages of your application, right? Various steps and figure out what's happening. So you can use it for logging, monitoring, if you stream data out of it, and just any other task. So there are ways to do it, and you can do it straight into when you generate the chain, you just pass the callbacks. And here it's a standard output callback handler, and you just pass that on and it would return everything. That verbose equals true that I was telling you earlier, it's basically acting like a callback, and it outputs, basically pushes out all the output of the what's it called? Like every step, all the text output, the standard output. And then the other one is you can use it within the chain, right? So, well, wait up. The request callback. Well, so you do it when you run the chain. So this one is when you define the chain, and this one is when you run the chain. So if you don't want it at every run, you can just kind of use it here. So that would be the difference between the two of them, right? And use cases, like the autonomous agents and agents like Baby AGI, AutoGPT. There are quite a few of them out there. Then they have an SQL agent, Pandas agent, CSV agent that are able to just kind of go through and pull this data and interact, make it easy to interact with a language model. Sorry, I was reading the chat. I'm getting distracted. Okay, agent simulation, Q&As over documents, all these things. So, but we'll go through some other stuff really quickly. So this was my actual kind of like overview presentation type thing. Do you guys have any questions at this point in time?
Yeah, I don't think I have a very good formulated question, but basically, like ChatGPT, they have the plugins, which is about taking an unstructured user input, and then they figure out, what functions or API endpoints to call with what arguments, and then they just introduced like yesterday functions, which makes them reliable to call functions and extract the arguments, and I think that's like a great capability, because it basically allows you to create chatbots that does things, that doesn't just answer questions. I can see like businesses can use that to, and there are companies that already do that. You can, ask it to file a report and they can do that for you. But LangChain seems to me it's a different thing. It's more like you give it a very structured input, like you're calling a function, and then it goes out and do all kinds of things. So I guess one of my questions is it right that they're kind of two different things? And then secondly, I would be really interested to see if there's anything in the open source world that can do kind of what, ChatGPT plugin and, what they're doing behind the scenes to take unstructured user instruction and then figure out what functions to call based on that.
So basically, I haven't touched yet the function calling into ChatGPT, but from my first impression is that they are trying to expand into what's it called, LangChain is doing, right? Because the agents and the tools are pretty much exactly that, right? So that whole part where the agent gets a question and then makes a decision, and then it's like, hey, I need to answer this question. What would I need to do? Well, I can go look online for it. So I can go and search Google for it and get back. You know how in ChatGPT, you're just going to choose, and you choose like the online access, internet access plugin. That's pretty much the same thing here, where you have a tool that allows you to go do a search in Google and return the data. So I think in the next stuff, I'm going to show some of that. So, but in my mind, they are the same exact thing. And I'm thinking, the way I'm looking at it is that OpenAI right now is trying to do more of what LangChain already does, right? So they're trying to make your life easier to just kind of use them than using LangChain. Now, there are a few other things, because I'm not entirely sure how does it work behind the scenes with ChatGPT and right now with the function calling, but I would assume that every time you need to make a decision, you need to work with the model. So you need to have a prompt and make an API call to the actual model. So that would be something that you get charged for, right? And LangChain does that. So when we were talking earlier that it keeps on looping until it makes this, is repeating until the agent decides no longer needs to use a tool, those are basically calls that are made to the LLM, right? So all this tool input, observation, and it just passed back to the agent. The agent, it's actually the call that's going to be made to the OpenAI API or the model API and get an answer back with a decision. So in my mind, they are the same thing, and I'm seeing it as OpenAI try to just basically add more functionality to theirs, the functionality that's already existing in LangChain.
Yeah, but there's a difference because OpenAI, both the plugin and the function thing they introduced, the user interface is through the ChatGPT user interface, whereas LangChain is, it's a programmatic user interface. Is that correct?
Can you say it again? Sorry.
Yeah. So with both the plugin and the function thing they just introduced, the user interface is still the ChatGPT user interface. With LangChain, it's open. I mean, you can have any user interface that you build on top of it.
Right. Well, so I'm not entirely sure. Did they add the functions to ChatGPT or just to the API part? I thought it was just the API part. Because ChatGPT, it's on its own, right? So
Yeah.
under ChatGPT, you have the plugins, which you didn't have under the API.
Oh,
So in order to be able to do that under the API, that's what those functions are for. And
yeah.
you could have done that basically using LangChain.
I see. Yeah, you're right. It's on
Right,
the
yeah, because ChatGPT, it's its own beast. That they've built their own interface, but it's using the GPT-4 model, GPT 3.5 behind the scenes. And that whole interface between the UI that you're seeing and the API, it's where they're choosing, where they're still having something similar to LangChain that asks the model, hey, which one of these tools that you've loaded do you think are useful? So which one of these plugins, right? So to me, they're kind of similar.
Yeah.
So
yeah, thank you.
all right, no worries. Okay, any other questions at this point?
Maybe a comment and a question, because it relates to what you guys were just talking about. It seems to me there's a battle over who provides the API to the developers. And there's the LangChain competition. There's OpenAI who's trying to provide its own. And therefore, this battle is going to continue. And then we're going to get a lot of other open source models that are going to come along that LangChain can integrate, but OpenAI may not be able to catch up with. Do you have a perspective on where that's all going to go? What do you think, Anton? Do you think we're going to get a proliferation of so many models that it's going to be hard for OpenAI to keep up, or is it going to go the other way and OpenAI is just going to run away with everything? We should just be going straight to their API. Because one of the things I've discovered is that as you try to do these LangChain integrations, a lot of people that are doing these eventually come back and just integrate a whole bunch of OpenAI APIs and eventually take LangChain out. Now, I know this is all really new, but that's what I've seen with a few of the projects on GitHub so far. Any thoughts?
Well, so there are a couple of things that just kind of try to clarify. So OpenAI provides the model the same way Google provides their, whatever it's called, Bard, the same way Cohere provides their models, the same way a lot of other open source like Salesforce has the blip, whatever, I forgot the name for Salesforce, but there are a ton of models out there. LangChain doesn't do any models in the sense of there is no model part of LangChain. So LangChain is just a higher level library that, for example, if you want to make a call to a chat in OpenAI, right? So you want to make a chat bot just with Python and OpenAI, right? You have to implement a list that you're continuously adding those messages. You need to parse the JSON that's coming in. You need to work with authenticating HAPI call and writing all the REST calls and all that stuff that you need to do for your endpoints, right? So you can go do that, and that's what I've done until I figure out LangChain. So at that point in time, you're basically writing a few hundred lines of code. Now, when you're coming to LangChain, all you have to do is say, hey, my model is OpenAI in this part of the OpenAI, and that's it, right? Then here's my prompt template. You don't have to do any F strings or any of that stuff. It's all done by LangChain. You don't have to do any of the request calls. You don't have to do any of that. Now, you also want to add this database. Well, with the memory, all you have to do is implement that buffer and have that buffer written to a database. Or you want to work with a, what's it called, with a vector database to store your data, do all the embeddings and all that stuff. Well, all the steps of getting all the data, tokenizing it, sending it out, get the embeddings back, store them in the database that you would have to actually write code for each and every one of these steps. It's done within a couple of lines. So LangChain is, all it does, it's a higher level library that makes your life a lot easier when working with these models. The other thing that it does really well is the chaining part, where you have, I want to do this operation, then this operation, then this operation, and this operation, and this operation, right? So rather than calling and waiting and doing all this stuff, you just generate a chain, you send the chain, or you basically generate all the parts, which model does what, with its prompt and everything, like we were showing earlier. So where was it? What was the chaining? Is this chaining? Yes. So you create your chain, and then you create the with the prompt, with the chain. You create another second prompt and another chain, and you can create 10 of these, right? And then you just say overall chain, sequential chain, and run this. And basically, in this chunk of code, in that one liner, basically, you are dealing with all the, hey, I'm making this call, I'm getting it back. Is this the right answer? Was this what I expected to get from the model? You know, oh, it is. Okay, let's move to the next step. Do the other chain. So you're eliminating all that from your code. You're just putting this simple sequential chain, pass the chains, verbose through, and you're done. And you get all this information back, and you see what's happening throughout it. So that's what this is what LangChain is. It's just a higher level library. That's it. It doesn't have any smarts behind it. All the smarts are provided by whoever has the model. And you can work with Hugging Face and get open source models. You can work with Cohere. You can work with any provider that you want to work with. There are no limitations on that. So now this is one part of the question. The other part of the question is, right now, OpenAI has the best model. GPT-4 by far is the best model. It's funny how there was this, oh God, I was looking at it. I think Falcon shut up as the top model in the open source models. And they show this huge list of, hey, like a leaderboard, we're the #1, and these are our results, right? And then with their model at the top. And then the last row of the table was comparison with GPT 3.5. And GPT 3.5 results were way, way, way better than the Falcon model. So currently, fortunately or unfortunately, nobody is touching GPT-4. It's just by far the best. The good thing, though, is the open source community is being hard at work to create these models. And yes, Falcon is still below 3.5, but that happened within months to have like 4, 5, 6, 7, 10, 15 other models coming out, and each one is better and better and better and better and closer to what GPT 3.5 and GPT-4 are able to do. So in my mind, what's going to happen next is that open source will end up to a point where they get better than OpenAI. And I'm actually excited about that one because you would have more options. You know, there is also the kind of like the fight between models right now. So you have Cohere. Cohere had their embeddings API was like, I don't even know how much it was, but like almost like 100 times cheaper than the embeddings API from OpenAI. And there's just a ridiculous number how much cheaper it was. One of the things that they've announced yesterday is that they've reduced the prices for OpenAI API. They've slashed the prices by, I don't know, 10x or more. I don't remember the numbers. I'm really bad when it comes to that. But they slashed dramatically the cost for running embeddings through OpenAI. So this pressure on them to get better, and it's also the community starts building up tools that are better and better and better. So in the end, we're the ones that are benefiting. As long as we're able to figure it out, hey, this model does this different task better and cheaper, well, let's use this. Or if you might not need GPT 3.5, a Falcon model might be great for your use case. You don't need the state of the art. Use one of those. There's so many other ways to do these type of things. And LangChain is the one that allows you to just basically change. If you don't want your LLM to be OpenAI, well, put Cohere in there or put Falcon, and you're fine. Pretty much most of your code will stay almost similar. So that's the part that makes LangChain kind of like very useful. That whole unification and kind of like one, I don't even know how to call it. It's just the one way to call everything, and it's interoperability with models and everything. So that's kind of how I see it. Make sense?
Oh yeah, sure. I kind of see it. I'm trying to draw an analogy to previous API wars that have gone on. You know, it
Right.
seems to me like it's, I don't know, it's like the Microsoft Internet Explorer battle versus the open web.
Right. Yes,
Right.
exactly.
Yeah. So you've got this higher level abstraction layer that you have going on with LangChain, and it's up to us developers whether we're going to fall into using the OpenAI APIs,
Right.
or are we going to stick with this higher level abstraction layer that gives us a more generalizable capability?
Right. So, but it does the same thing. So you can do the same exact thing with both LangChain and directly with OpenAI, only it's a lot easier with LangChain and a lot faster to develop something with it, right? So,
but fundamentally, it seems to me all LangChain really does, it's really not that much. It trains, constrains, and then gives context and a focus to the LLM. And it makes those things granular and allows you to put those things into a chain or into some logical form.
Right, exactly. It's all it does. But it reduces
it's very simple.
Code base. It reduces your code base from, because you can do the same exact thing probably in 200-300 lines of code. Now you can drop it to about 30 to 50 lines of code to the same exact thing. So that's the beauty of it, right? That makes it easier. So
I have a follow-on question. Have you discovered anything with regard to costing? That is, can you parameterize the costs with the individual chains and use that within LangChain, or have you seen any utilities for that? Because OpenAI gets really expensive.
Well, that's what I was saying. Depending on the model that you're using, you can, and especially for agents where you have multiple redundant calls, you might want to choose like a GPT 3.5, or you might want to use an open source model that you run locally. So yeah, that's something that I guess everybody's fighting with right now, because I was just there was some news that there is a new plugin for WordPress that allows users automatically generate text and do all these things straight from WordPress, right? And my whole point was, okay, how much does it cost? And the cost, it's $10 a month. And I'm thinking of it, I'm like, you will
No
run
way.
through $10 a month using GPT-4 like it's nothing, right? So I am pretty sure that what they're going to do, they're going to use GPT 3.5, or they're going to use other models behind the scenes and not use GPT-4 at all, which in the end is just going to create a spammy new world of crap, basically, that
Right.
shows up everywhere. You know, this whole insane barrage of spam that's going to hit the internet world. So that's part of what you actually need it for, and gotta figure it out what's the best way to deal with it. But
Yeah,
if
actually, I'm thinking about it as we're talking. This is just off the top of my head, but we need a library to go out and talk to the OpenAI APIs or whomever we're using for third-party cost-based LLMs and be able to figure out what our current cost is for the
So-
execution, and then go down a different path if we want to, save money and use an OpenAI model.
Right. So you can look at I haven't used it through the API, so I'm not entirely even sure if they have an API for basically costs, but they tell
Oh, I'll
you
look real quick.
every time you make a call to OpenAI, when they return the JSON response, they tell you exactly you had this many input tokens and you had this many output tokens. And if you take those input tokens and multiply them by the price per token, and the output tokens multiply them by the price per token, you can figure out each one of those calls, how much does it cost. So I haven't seen that one in here in LangChain. So I'm not entirely sure if it's possible to do it through LangChain. But
I'm thinking of like a supplementary library for LangChain might be nice to do cost accounting.
They might have something. I am pretty sure somebody have thought about it. There are 900 people working on this thing, so they might have thought about it. But
well, that's my big issue at the moment is, man, this stuff gets expensive fast.
Right, especially, so that's why try to use GPT 3.5 as much as you can. That's their, well, the 3.5 Turbo, I believe it is their cheapest one. It's like 30 times cheaper than 4. And that it might be good enough to run agents and make decisions. It's not good enough to output nice formatted text or run some crazy logic, but it might be able to parse things and make decision to, hey, I should probably go on the internet and do some more research for it, you know?
Well, here's the way I'm currently thinking about it. You set it up so that you develop to 3.5 turbo, and then you've got everything set up through LangChain so that when you want to switch over to 4, you have it all automated through LangChain, and all you're doing is switching out the model.
Right.
And then you've hopefully got a better user experience as a result.
You definitely do, but you have also 30x the cost.
Yeah, exactly. And that's why I bring up the costing issue.
Right. So probably it might be better to have 3.5 that stays in production as well for the kind of like the lower end tasks, and then use 4 just for the higher end, for the final result type thing. You know what I mean?
Right,
So,
right.
Kind of like throughout the chain, if you think that this task needs to be done, maybe you do that with 3.5, and this one needs to be done. Maybe you don't even need 3.5. You can have an open source that's trained for it. So it's just, that's kind of like up to each developer to figure it out how to use and what to use it.
Yeah, because I mean, at the end of the day, OpenAI does not give you what the cost of execution was, what the cost of inference was for your call, for your API call.
So they give you the tokens, and if you take the tokens and you multiply that, you get the cost. They're not telling you exactly how much it was, but you need to know the price, the current price, and for that type of call, in the model, for the model, and then you can calculate each call automatically. The other thing, you can go in the back end, in the back panel for the OpenAI, for the platform, and you can see there your costs, usage.
Yeah, I can see it on the website, but that's a good point. I could look at I could use, if I take the current calculations or current cost of per token, then I can calculate the cost for
Right.
each call.
Yes. Yeah, because if you look at calls, all of them give you the number of tokens, input tokens, output tokens.
Yeah, yeah, good point. That's a great point. Thank you.
Yeah. Okay. Any other questions? Because I'll have to kind of run through this. We have another, 12 minutes, 13 minutes, unless you guys don't mind staying a little over. But okay, so I found this one, LangChain Cookbook, part 1, which I'm thinking, I thought it's pretty awesome the way he went in and took the documentation and explained it a little bit better. Just open it up more and got it better, and shows more kind of examples. So the part 1, it's almost what I've done through the presentation. Part 2, it's the use cases. So I'm going to go really quickly so you can see the chat messages here, the way we're talking. So see how you have a list of system message, human message, and those are kind of like, and this is the AI message here. And this system message is usually what you pass as the context. So this is where you would put when you work with a vector database. When you return all that information that's closer to your query, that's what you would put in the system message. You're just adding it in there, saying that, hey, you're a nice AI bot, and here is some information to use for this, right? So that's that part. So documents. So when you have the documents, remember when it's kind of breaks it down and tokenize it, it's the nice part, it adds all this metadata to it. And it's very easy to figure it out. Where's the source of it? And basically passes an ID to each and every one of these documents. So if you are doing it, the tokenization kind of manually, and I haven't looked in detail to see, but when you do it manually, you can actually figure out the page that you are in that PDF or Word doc and add that one here to the metadata. So that way you know exactly this chunk, it's from this page in this document. So it's a lot easier to find it that way, right? So the models are that interface to the AI brain. So here, OpenAI, and you can just pass the model name. The same thing, you just do the chat OpenAI model right here. The text embedding, they're using OpenAI embeddings. These are pretty much state-of-the-art models right now, and it's just they're the best ones out there, and it's hard not to use them. But yeah. So prompts, we remember we were talking about prompts and prompt templates. You just have the template and you just kind of pass the variables and it does the replacement for you. And you can say here, like an input variables, you can have a ton of these variables all throughout the text. Selectors, these are a little bit more kind of like just a little bit more in detail, where you can use these ones to show that, hey, this is the input and this is the output, to kind of like help it not with just a zero-shot type prediction, but to somewhat train it a little bit. It's like a little bit of context training, or training to context, right? Where you're just passing some of that information in there. And then once kind of like got stream, it just kind of gets driver, output is in a car, right? Pilots in a plane, because all these examples are pilots on a ship, pilots in a plane, driver in a car. So I guess it's kind of learn them and returns, or actually, no, these are the examples. Sorry. You just pass all these through, and then when you say input, the output, it's gonna, for student, the output will be classroom. So it kind of figures out the correlation between the relationship between input and output, right? So the output parsers are quite awesome, because most of the time you get the text, and if you're kind of trying to pass that text further down the road, it's better to have it into a nice format that you can actually parse and work with. So it's easy to just kind of train it to give you this type of output format where, hey, it's returning a JSON, right? So, and you just parse the output, and all of a sudden you've got the output in a nice way that you can work with. It's a dictionary that you can work with in Python, right? So the example here is just it passes a bad string and a good string and teaches it, hey, you should return it like this format, right? So indexes, the same thing. Document loaders, like we were saying, you can just load this text, and text splitters, if you want to go through that, retrievers. So these are the ones that are kind of getting all this data. So you can use face. So this one is the Facebook's in-memory index. So it's very easy to just kind of, if you have a small amount of documents, you can just load them in memory and it's super fast. And vector stores, they're just basically the next step up from that index, from the files. Memory, you have this, the same, we were kind of showing it earlier. You add the user message, AI message, and all these things, chat message history, and it keeps that history for you, and you can actually look back at it. Chains, remember how I was saying that you have the simple sequential chains where you just kind of pass them one after the other. And this is that output from the verbose true, right? So entering the simple sequential chain, and then this is, so basically the prompt, this is kind of like an interesting, and you can see a little bit of the agent here. So your job is to come up with a classic dish from the area that the user suggests, right? And the user location is going to be passed in there. And when it says, and the second template, it's like given a meal, just give a short and simple recipe, right? So you can just do location chain first and then meal chain. And basically, once they said Rome, then the first answer, the location chain, is a classic dish from spaghetti and carbonara. And then basically with a little bit of a description, and then it does the second chain where it generates a recipe for it, right? So you can do all this. Summarization chain, they have a lot of ways of dealing with summarization, because if you have a huge amount of data, like in a book or something else, you can take it and you want to get a summary of it all, you won't be able to pass it all through. And there are different algorithms. The one that's kind of like most used is like a map reduce, where you take the whole amount of text and you split it in chunks, and then you run a summary for each chunk, right? And then once you run summaries for each of the chunks, you take all the summaries together and you summarize them again to get your final result. So that's one way. This is kind of like the most popular. Another way of doing it is you take a chunk, the first chunk, you summarize it. Then you take the second chunk and you add it to that summary and you summarize these two now. And then you take the summary, take the third chunk and just add it to it. And you can do this kind of like sequentially like this until you get through the whole document, and you get kind of like a better result in the end, because it's not just separation, but it keeps on just adding to that original initial summary, right? So there are multiple ways, and you just basically choose what type of chain type do you want to use. So here they're using the map reduce. This is that first one. I don't remember the name of the other one. I think there are 3 or 4 of them, but you can find it in the documentation. So this is kind of like showing that this is one chunk. So write a concise summary. So 1, 2, and then once it gets these 2, I guess it just puts them all together and just creates the final chunk, right? Agents, we're talking about agents and tools. I'm kind of running through, so if you guys want me to slow down and focus on something, just let me know, right? So
And there was a request to paste the URL to this cookbook into
Yes,
the chat.
here it is. Yeah, I'm trying to stay away from the chat in a way because I'm getting distracted reading them. Sorry, but I will put the. So I'm recording it right now, so I'm gonna have it recorded and edited and put it up probably in the weekend, and then and I'm gonna put it up on YouTube, and then I'm gonna put a link to it in the chat for the meetup. So that way I'm kind of keeping everything together. And that's also where I'm gonna put the links for this cookbook, right? So this whole repo, it's quite awesome, and we're gonna go through some more things. So here, basically the way, sorry, I'm going back to this. And yes, I put the link in the chat. But so basically here, this input, it's kind of like a more of a complex question. And the question is, what was the first album of the band that Natalie Berman is part of, right? So first of all, the model needs to figure it out, who Natalie Berman is and what band is she from, and then figure out what's their first album, right? So this is kind of like that agent that needs to think a little bit more. There is not a clear path ahead, but it needs to figure it out. So if you look at this one is the kind of like train of thought through that verbose equals true. It's the parameter. So it shows I should try to find out what band Natalie Berman is part of, right? So searches online for Natalie Berman band. And then the observation or the return of that, it's basically saying that Natalie Berman is an American singer-songwriter. She's one half of the duo Wild Bell, right? So it figured all this part out, and then thinks that, hey, I should search for the debut album of Wild Bell, right? And searches for this Wild Bell debut album, and the album is Isles. So the next train of thought is that now I have the final answer, and returns the final answer. So Isles is the debut album of Wild Bell, the band that Natalie Berman is part of. So this is basically how that works. And you see here, you have the load tools, and you pass a list of tools. So here is this SERP API, which is basically Google search almost, right? So, and this is like a zero-shot reaction description. So it's just basically, you figure it out. It's nothing more fancy. It's a zero-shot means that it's not pre-trained. It's just like you give it something new and he figures it out. It's not something that it's been pre-trained before. So that's just kind of the very simple logic, and everything's done here, which is this whole logic. If you try to do it without LangChain, it's quite a pain, right? Because you need to come up with that idea. They've already done this. They've already kind of figured out what ways to use it. And you can actually, you don't have to use LangChain on everything. You can mesh LangChain with just simple Python, regular Python and other libraries, right? So that's basically the output. So this is one of them in the Park 2. This is the one that I kind of wanted to go through. I guess I'm going to take a few more minutes and go over this one as well. So summaries of short text, right? So remember we were talking about that. You just kind of pass the model name, and you want to keep the temperature to 0, so you don't have any kind of literary answer. You want to have a very clear and concise and explicit answer, right? So you just pass, hey, this is the template. Please summarize the following piece of text and respond in a manner that a 5-year-old would understand. So that's kind of like the nice part of having these templates. You can create these and reuse over and over and modify them and kind of like tweak them until they work, and then keep on using this, right? So then you can pass this text and just kind of go through this whole thing, summarizes, this is the whole prompt, and then it outputs the nicer, cleaner text, right? Then summaries of longer text. This is what we were talking earlier, when you just kind of have a big chunk of text, you split it into different ones, in different chunks, and you use those ones as well. So we've looked over that, like Q&A over the documents, right? So you have, this would be the context, which is something like you were talking about having from a database, right? So that whole context can be generated and added together to this LLM, where you pass the context and the question, and it's basically it figure out this is the context, this is the question, who's under 40? Well, Rachel. So Rachel under 40 years old. It's kind of like very easy to do that. The same embeddings, we looked at that earlier, and the same thing here. It's an example that has a little bit more, because you have 74,000 characters, and then it's using this text splitter to split it in chunks of 3,000 characters, right? And then it also runs an overlap of 400 characters between these chunks to kind of make it not as the vectors that return right now, they're not super separate, and they're just kind of a little bit more closer together. So they're in a way more clustered a bit, if you want to do that. And also, I would assume that that overlap allows it to kind of figure it out that certain parts of the beginning of the end are not as important, but that's kind of just like me, the way I'm thinking of it. So, and then basically, what does it do here? And it's using the embeddings, the OpenAI embeddings, and then just basically runs this doc search from documents, and it passes the docs and the embeddings. And the embeddings, this is the model, right? So in 2 lines of code, you basically take this whole chunk, run it through the embeddings, do all these operations, put it into the database. This is the phase 1, it's in memory. So, but this is the part that makes LangChain amazing. It's so easy, because you can say here, instead of say a phase, you can have pinecone, or you can have Weaviate, and it works the same. It's just super easy, right? So now you can do the Q&A, and it's just like the retrieval QA from chain, and you can just pass all these things. Doc search as retrieval, right? So you just pass the doc search, which is here. So that's the part that does that whole similarity search, figures out what's useful, and pass it back together with the question. Right. Extraction, well, I'm not entirely sure. I'm not entirely sure what does the extraction part. Instruction, you'll be given a sentence with fruit names, extract those fruit names and assign the emoji to them. Return the fruit name. Okay, so these will be the fruit names, and just returns this whole thing. But what is so specific about this? Yeah, I'm not entirely sure. I haven't looked at the extraction part. So that's that. And the evaluation. The evaluation, it's quite an interesting thing, and it allows you to continuously figure it out if your model is returning the stuff that you're expecting, right? And you can just build on this. So it's a little bit more on the complex side, but nothing it's really hard with LangChain. It's just a matter of kind of going through it. And then querying tabular data, so you can actually get SQL database, and you just pretty much run this whole chain, and basically you're just passing a question: how many species of trees are there in San Francisco? And it figures out that, hey, select count distinct Q species from SF trees. So it figured out what's the table name, it figured out what's the column that you're using, right? So it's quite powerful what you can do with this in a line or two of text, right? The same type of thing with SQLite, and this is more like, and see, they're kind of using GPT 3.5. You don't necessarily need the 4 for a lot of these. So code understanding. So I haven't been through all the details here, but I would assume it's just kind of getting Can you write the code to use the process.extract on function? Okay, so it's generating some code. Choice in New York, query New York, best process extract one query. Okay, so it just basically wrote a very quick query for the process extract from SQLite, I believe it is, right? I'm not sure. Yeah, I'm not going to go into details, but this generated this code to extract one from these choices. So actually, no, it's not SQLite. All right, never mind. So interaction with the API, the same thing. It's very easy to just kind of like, hey, this is the base URL. These are the endpoints that you can use, and then it's gonna make, it's gonna figure out what API to use, right? And just return the information from whatever it found in there. So this is amazingly powerful. You can figure out your endpoints that you're gonna work with and let the model decide then which endpoint to use and figure out the interaction with that endpoint and get the returns and parse all this JSON data into something that's readable. So this is very, very powerful, you know. So, and then chatbots, the same thing like we were talking about. And if you look here, it's to just make a chatbot. It's what? A few imports, then a template and a prompt. Yes, it kind of turns the memory on, makes the chain, and then just predicts. And then uses this whole chain with the new input and keeps on adding and adding and adding to it. So it's extremely easy to generate all these agents. So well, basically, this is kind of like what we were talking about earlier, where you have this one, it's a search tool and the request tool. So it allows it to figure out, so what is the capital of Canada, right? So it has this agent toolkit, which it's using these two tools, the search and the requests, with a description, so it knows exactly, hey, I'm using this search when you need to search Google, or this one is useful when I need to do a request and kind of like call to a URL. And then let's see what it thinks. So what is the capital of Canada? And I need to find out the capital of Canada in search, right? Capital of Canada, observation, looking at bill, credit card. So this is a huge chunk of text that came back from that search. It doesn't make much sense, but somewhere in there, it figured out that there is Ottawa. So let's see. Ottawa. So Canada's capital is Ottawa. So it figured out that, hey, it's one here. Then next, it's Ottawa is the capital city of Canada. Then Ottawa River, and it's Ottawa, Canada's fourth largest city. So pretty much out of these recurrences, it kind of figured out that yes, Ottawa is the capital of Canada. So this one, it didn't need to do both the search and the request. So now I guess they're doing, tell me what the comments are about this web page. So it passes a URL. So right now it's basically figuring out, hey, I need to find out what the comments are about. Action is search, inputs comments on HTTPS. It figure out, why is it not using the request page? I would have thought it would be using requests, right? But tell me what the comments are about on this web page. Well, this one is not something that I would have kind of thought that it's a good answer. I would actually would have expected it to go look here on this actual web page, grab the comments, and basically make a summary of what the comments were about. What are they talking about on this page? So, but yeah, this is This is a pretty good one to show you chunks of code. And they also have data generation here. And there are quite a lot of notebooks. And this is the other one that I wanted to show you. It's like this, yeah, ask a book a question. So if you look at it, it's basically, he's gonna load a 130 pages PDF about data science. So there's this field guide to data science, and it loads it. And data, it's basically to go through a PDF and get all that information and parse it and everything. It's a little bit more complex than just a one-liner, the way is this one right here. So you get the data. Now, and it tells you, hey, you have 126 documents, so those are the pages. Each page comes in a document. And then there are 2,812 characters in your document, right? And uses the splitter to just chunk it up in 2,000 characters. So it says that right now we have 162 documents. So it took all that data, every 2,000 characters, split it, and it ended up with 162 documents. And it's going to create the document embeddings. So I'm not sure why this is using Chroma, because later down the road here it's using the Pinecone. So probably he just forgot about it, so it's not using Chroma, but Pinecone. So those are your API keys that you need to pass. And then again, creates the embedding models. And this is part of Pinecone, where you have to initiate your index and pass the name, and then basically generate this doc search and gets this from text and passes all this text, the embeddings, and it passes the index name, right? So now, right now, this whole thing will be when it runs this line, basically, it's gonna take all these documents, all those 160 documents, create embeddings for them, and upload them into the Pinecone database, which is quite amazing how much stuff happens behind the scenes, and it's all done. And then you can actually run a quick query. What are examples of good data science teams? And basically runs this on this document search. In there, it runs a similarity search, which should have been set up in here. I'm not sure. When you set up the index, you got to choose what type of similarity do you want. He didn't do it in here, but I'd assume that by default, it's the cosine similarity. So runs this query, and this doc search similarity search will create an embedding of this, run through the database, and figure it out the docs that are closer to these ones, or documents that are closer, and they're in kind of like ordered by similarity, right? So this is the first document that's kind of the closest. So what are examples of good data science teams? And here, intelligence and cloud infrastructure development work. We saw the need for a new approach to distill value from on-premise data. Probably the most multidisciplinary team of computer scientists, mathematicians, and domain experts. So the answer is in there, basically. So right now, what's it doing here? It's importing this, and it's doing the question and answering stuff. So, oh, no, sorry. So this is basically, sorry, this was not the similarity search. This is just basically, sorry, this was a quick similarity search, but it had nothing to do with the LLM, right? So this one shows you that using this, to, converting and embedding this chunk here, docs0, the first item there has the answer in it, right? So now when you pass this question and this chunk to an LLM, it will format this and it will return the proper answer, right? So this is what he's going to do next here, where he creates the LLM's OpenAI, the question and answering one, loads that one, and this is another query that he's passing. That's kind of like threw me off. He should have used the same exact query to actually see the return the results. And then when he runs the chain based on this, what is the collect stage of the data maturity? Runs a doc search. That doc search comes back with a chunk like this. Then it passes everything to the LLM, and then when it runs here, the LLM returns this. The collect stage of data maturity focuses on collecting internal or external data sets, blah, 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 right? So it's just kind of like the principles that I was kind of trying to get through. Okay, I kind of ran through this last part. I'm hoping I made some sense.